Okay, so hi everyone. If you don't know me, my name is Senan and I make videos on structures, algorithms, and mathematics. This is a bit different format that I'm trying to do. And if you like this type of format, do tell me in the comment section below. As I usually do, I would solve this mathematics integration. I'll go through the thought process and what thinking while solving this problem. So what I am seeing is I'm seeing a structure like this, a square root of something, and divide by x. So the first instance or the first thought that I get is, can I do something by pushing this x inside the square root, like something doing under root of x cube minus 1 over x square inside that, right? We would get something like 1 over, and if you write the whole question, you get something like this, and I don't see a way. So this is something that goes in the mind. It's not actually, I don't actually write these things on paper or so. So okay, there's this one thing. Can I do some sort of yes, I could do, right? So let's use this, and let's say x cube minus 1 is what? Let's use t squared. Why t squared? Because when t squared and root, you can just cancel out the square and the root. I know there's a plus minus sign involved in this case. That is taken in the case, like you can just assume that the domain is such that the value is positive. That's one thing. Now I can do this solution, right? And if I do this, get is now I define, so 3x squared dx to 2t dt I get. And let's do a bit of substitute, so or rearranging first, and then we do these. So would now give me, okay, so it would be somewhere here on the screen, so I need to keep that in mind. I don't write. So what I would be getting is dx equal to what? Dx is 2 times t dt, and that goes on 3x. So you get this, right? Obviously this dx you would like to have totally in terms of t, but you see, when we move ahead, we would have a simpler explanation. The question now becomes is this t square under root, and in place of dx I write 2t dt and 3. So there is this 1x already, and 3x square is this, and let us write this dt right here. So okay, what can you see? So assuming this comes out to be t, and you can always take since this is an indefinite integral, right? So you assume that the domain that we take is for the one corresponding with this basically being equal to. So what I do is I this, and I can say 2t square. So this would give me t, and this t, so combining both we get t square. I get this 2 here, and in the denominator what I get is 3x cube, right? So single x and this squared term. Okay, I could rewrite this as take the constant out of the integration sign, and I write square over x cube dt. Okay, and we definitely don't like this expression because it's dependent on t, so we cannot, so not even by mistake, don't take x cube out of this integration, assuming that no, it's not like that, because x depends on t. So this is actually a function of t, and since this x is t, we pull that out of integration because the variable of integration is dt. Okay, so what we did, we started with this, right? So what I could say is, from this I can, x cube is t square plus, right? I get this, and this is what we got, and let's do the substitute back. So we get 2 over 3 integration of t square over x square. X cube is what? T square plus 1. And and this is something that, like, right, this is something that is common. If you have a habit, you know what would be. And now I will use a simple algebraic t square. I'll add 1, and I'll subtract 1, and I'll say dt square is 1, and just do a few more. You'll get is t square plus 1 over t square plus 1 dt. We'll have a bracket around here minus integration of 1 over t square 1 dt, right? And clearly the first thing you should do is just cancel this out. What you get is 2 over 3 integration of dt minus, and now this I should tell you about. This is what is the integration of this value. So since I've not integrated this yet, write that function first, t square plus 1 dt. So what you get is something like this. And if you remember, so you do is perform a substitution on this t. You take this as like t is equal to tan square and tan square. So, oh no, not tan square theta, but tan theta. And what you would do is you would say that t square plus 1 tan square plus 1. Hope I'm not covering this text. I would be there here. Anyways, and is what if I correctly this is secant square. Okay, but what would be dt in that case? In that case, dt would be equal to what? Differentiation of tan is okay. I forgot. Yep. Secant square theta d theta d theta. And if you do the addition here of this, what you would get is, so let me just rewrite this whole equation. So 2 by 3, and let's do the integration of dt would be t itself, and then I'll do a minus. So to give me is integration of secant square theta d theta secant square theta. I cancel this out and I replace this here, so it would be d theta. And now you would be able to see it's going to happen is 2 by 3, and let's keep the t for what it is, minus integration, or not exactly integration, but itself. And in the end you just add a constant for this as well. You just add a constant c1. So this c is basically c1 plus c2. C2 is the constant integral constant of integration that you get, c1 minus c2, c1 plus c2 regardless, but you would get, and this is that term. So you're done. This is your answer, 2 by 3 and t minus theta plus c. This is your final answer. But you would say, Sinan, where is the x? Did with what? Did with x? We have no x in our answer. So what I'll say is just do the back substitution. So okay. So let's t is tan. Fine. We started with what I could say is tan inverse t theta, which can be also written as arc tan theta. Depends you use this notation or this notation. Basically, I'm comfortable with this. I know this one as well. So now we get is 2 over 3 t minus tan inverse and plus some constant. Okay, so the next step is, Sinan, this again I'm not able to see x, right? So what you do is, again, you back substitute what was that? So x cube minus 1 is square, is x cube minus 1 is my t square. So t is equal to square root of x cube, assuming we are taking the positive root, given the domain is for its positive root. If you can take the positive root. If the domain is given, you need to calculate that the positive root, negative root, but this is indefinite integration, so leave that up. So what is this value? So now what you basically do is 2 by 3 t is what? Square root of x cube minus 1 and minus tan inverse, so tan inverse of x cube minus 1 and the root. And so question, I'll just shift this up. So the solution for this over dx is this. So we are done, and yep, this is complete. I assume this is the correct solution if I don't make any mistakes. So yeah, that was the whole video all about. If you enjoyed this, do tell me something about how can I improve this, because this is slightly a different format and it's been a long time since I have solved integration. If you scroll back to my channel, you won't find integration a few 50-60 videos. So yep, that was about this video. I tried this, the clipping mask you're seeing on me is something new that I'm trying to do again. And yep, that is the whole video. Thanks for watching, and I'll see you in the next maybe integration or some programming video.